Alright, so today we're going to talk about streaming stuff inside UPBGE using GeoNodes and UPBGE guts. So I'm going to start off by deleting the default cube. I'm going to add a curve. This is what we're going to stream along. And then we're going to add a plane. We're going to do array, fit curve, pick the Bezier curve. And then we do curve, pick the Bezier curve. So now it fits on there, right? Then for the streaming part, we're going to add an empty cube. We're going to give it a constraint, path, Bezier curve. So it's on the curve. We're going to say follow curve, so it points the same way as it. And then when we crank this offset, it moves it along the curve. So now, add empty, single arrow. We're going to call this time. We're going to give it a logic brick setup. And you could just have the player moving along the thing move the path along the thing too. But this is for streaming, like the game moves no matter what. Like the old side scrollers. So now we do always, and then motion. Alright, so this is going to move down always. So we grab it. We add GeoNodes to the road after a weld modifier. Bring that up above there. So in the geometry nodes, we can do input position, and then input object info, and then we want that empty. We'll rename the empty right now. Stream center. So we do vector math, and then distance, and then attribute, or not attribute, geometry, separate by geometry, and then we're going to do face, distance, and then we'll do utilities, math, less than, and then you could type like 45, 15, so you can see this is like the distance away from this that the road will be filled in. So now we can grab time, and we're going to copy its Z position, copy as new driver, then we're going to go to the stream center and go to its constraint and do paste. So now when I move time down, it moves the stream center forward. Alright? So next, let's see what we got going on here. 5 minutes. So next, we can do a delay like every 15 frames for this to move up. So this will move forward every 15 frames. So we're going to duplicate the stream center. We're going to do camera center. And the reasoning for this is the camera needs to update continuously, whereas we want the road to only update periodically. So we have a camera center. We have a time. Camera time. So we take this and its Z component, we copy it, copy as new driver. So we go to the camera center, we go to its constraint, and we paste this in over. So now, when I go to camera time, this is going to be always, every frame. We don't want rotation. Weird. -0.5 for this, or we'll say -1. So it's every 15. And then this one, if it's every 15 frames, 0.1 should be the same. Let's see. I'm going to have to pop something on the camera center so we could see it. Add mesh cube. Camera center, Control P. Alright. Huh. Oh yeah, I have to do this. So we do override transform priority on both of these, the stream center and the camera center. Alright, it's going backwards. That's right. -0.1. There we go. So now the camera moves continuously, and then the road streams every 15 frames. Looks like I need to take this. Let's see if that does it. Yep. So now it's perfectly centered. So it's streaming the camera every frame, and then every 15 frames we update the road, right? So then next, when we update the road, we're going to need to actually set a property in the road. Update. Alright, so now that I have that, we assign property update to 5. We set it as an integer. And then inside the road, we do property. Oops, this is what's supposed to have update. Alright, there we go. So now, every time the time moves, it sets the property update to 5. So now, we need, if the property update is greater than 0, or greater than 2, and then edit object, or no, property, sorry, add -1. We have to set this to true level pulsing, so it'll reduce it down to 1. And then we do property is equal to 1. We do Python, and we do tap here. I'm going to do a text. Templates, Python, game logic simple. Own.reinstance physics shape. I think it's physics mesh. I think it's shape actually. We'll see. And then file save as stream test. Alright, so update 0. Alright, so we should see this pulsing. We'll set it so you can see the debug properties up here in the corner. Alright, so that's running. So now I need to set this to triangle mesh in physics. And then we'll turn physics visualization on. Okay, it's not calling the script. We might have an error. Let's see. Every 15 frames, but it's never getting a chance to do it. Oh, duh. Greater than 1. There we go. Alright. Physics mesh. Okay. There we go. So now we're streaming inside the game engine. So with setups like this, we can cull a bunch of the geometry or not generate a bunch of the geometry. And it makes it so we can stream worlds very quickly. So there's the basic setup of one. Let's see how long we are into this. We are 11 minutes. Okay. So there it is. So here's another streamer that I set up the other day. And this is spawning buildings that are made of instances, and we're updating both sides of the road. And you'll notice we're getting 270 frames per second, 300 frames per second. We have a pause when it updates the shapes sometimes, and when it reinstances the physics shapes. So it's generating all this in real time. I'll just go ahead and zoom out so you can see what's going on here. So this gets moved around here, and then these get snapped to it periodically, and that tells it when to update. So we're not updating constantly, we're deciding when to update. So let's see, I think it goes this way, so we can go all the way back this way. So deciding what to update piecemeal actually makes it much faster. And we don't have anything like AMD super resolution yet, or anything to be able to boost the performance. EV rewrite is on the way, should be here pretty soon. And before we go, I will just show some stuff on Chrome. So let's see here. I have another streaming system. Looks like I went back too far. Trash Panda, there it is. So this is kind of my main project. I walk away from it and come back to it, called Rectified. And this is all generated in real time. I have real heavy depth of field and some things like that for atmosphere. You'll notice on the signage it says food and ammo. Those are generated randomly, but there's like food, ammo, and medic at the moment that it decides from with an index using a random choice. So here's that file. So again, we are moving along a path, and then we choose when to move empties to update the left side of the street, the right side of the street, and the road. And we split the updates. The more the updates can be split, the less the impact you have on your streaming. So it's again the same concepts that I showed in the streaming of the road at the beginning, but applied to a city. Alright, and then another use case is the particle fountains and particles. So one thing I was able to do is run particles inside the game engine, and then while it's running, I record copies of the mesh and set them aside and disable their geonodes. So what it basically does is caches that frame, and we add those to a collection, and then we can use their collection indices to access them. So basically I cached it using UPBGE, and then each frame at the end of the simulation, we'd take the data, the evaluated data, and write it back as the original. So it takes the positions and just moves them around, basically. So we can simulate physics in real time using geonodes plus UPBGE. So we'll go into the evaluated data real quick here. File, open recent. Looks like we have to go a little further back in time here. So I'm going to look at the videos again. Here we go. So we have an evaluated mesh, and then with mouse over, I get the indices of the slot, and then I pass that into the geonodes up here. So I'll go ahead and open that file now that I know it's named. It's called geonodes inventory. So we'll pause that. Oh, I have to open it from here. File, open, Google Drive. There we go. So we have all of these get generated. They get their texture from one of these, this slot info. This is their UV info. And then there's one dot here for every single face over here. So when we run this, when I mouse over something, if I click, I can adjust the dot that's associated with that face and set what UV it's using. So that's what this is. So if you're mousing over, if it doesn't have a BVH tree, grab the BVH tree. And if it does have a BVH tree, then use the BVH tree. We get the mouse over position, and we use it, and we set the slot there. And then this is to fill a slot right here. This is to adjust the indices, adjust the vertices position associated with that slot. So we can use this stuff to do like tic-tac-toe or an inventory in a game or like a menu at the beginning of the game or whatever. So yeah, we can edit data and we can display data and we can get the evaluated position of the data. So these are important snippets right here. So I'll leave this open for just a second here. Okay, so I have about 10 minutes left here, so we'll go ahead and see what we have on deck. Oh yeah, so I have a new generator here. So this generates random buildings, and it's going to be inside of my streamer. This W value is the W value for a Musgrave texture 4D. These are generated based on, let me turn all this off real quick. There we go. So there's the base shapes that we use to generate those. If I turn this on, it extrudes edges randomly out. And then it does again, but when it casts when it goes to put the edge out, it raycasts where each edge would go. And if there's face there, it won't do it. So we can get these complex shapes. So there we go. We got some generated buildings that have lots of different shapes. These kind of overlap just a tiny bit, but I think that's because of the simple deform. Nope. I'm going to have to check that later. Well, I'm going to have to give up the last 8 minutes of my time. Thank you for watching.